Lesson 6.1, the polygon angle sum theorems. This lesson starts out using polygons and breaks it up into things that we know and have used lots, and those are triangles. So it says use the tools to draw a pentagon. Now you can use these tools over here, and to remember to do that, you hit polygon, and then you just click pentagon is 5 points, so 5 points for 5, and then you go back to the original. So there's my pentagon. Then for each side of the pentagon, draw the lines. You can also do that and go connect them with the lines, but it has a picture of them right here. So you don't, it's up to you whether you actually do it, and you can do it to all 5 sides. It's up to you. But basically it says choose one pair of lines, and I'm going to highlight them, and hopefully this works pretty well. Of these 4 angles at any given spot, and I'm going to change the colors. And the reason why I'm doing that is because hopefully you remember these are vertical angles. The greens with the greens and the blues with the blues. So choose one pair of lines that intersects at the vertex, there's a vertex of the pentagon. Is each of these 4 angles formed at the vertex an interior angle or an exterior angle? So look at all 4 of those. And I'm hoping you can tell there's only one interior angle here. And that is located inside interior right here. This bottom one right there. Now, all 4 of these angles, all 4 of those angles, 1, 2, 3, 4, all 4 of those, 1, 2, 3, 4. See how there's only one interior? That's important. All right, make sense and persevere. It says if we drew a hexagon, so 6-sided, and the lines are included in the sides of the hexagon, would the relationship be the same of what we just talked about as the pentagon? Of the intersecting points at that vertex, would they still have 1 interior and 3 exterior? You're going to have to answer that. Explore the polygon interior angle sums. So it says, how does the number of sides of a convex polygon, so convex is sticking out, not dented in, so convex polygon, n, the number of sides is n, relate to the sum of measures of its interior angle? The n, number of sides is 3, and there's 1 triangle. 4 sides has 2 triangles. 5 sides has 3 triangles, 6 sides has 4 triangles. So look at the relationship or the difference of those numbers. 7 sides has 5, and you can keep going and going and going. And it gets closer and closer, looking like a circle, the more sides you get. But it's asking you, what do you notice? What do you notice about this relationship? And hopefully you notice that whatever the sides are right here, you take the number of sides minus 2. See, the difference is 2. The whole time, the difference was 2. Hopefully, you'll see that there's always 2 fewer triangles than there are sides. How many triangles are formed by drawing diagonals from a vertex in a convex octagon? So if you need to, you can draw this, but an octagon has 8 sides. So if you drew it out, 1, 2, 3, 4, 5, 6, 7, 8, let's pretend like that's relatively nice. If I drew that, and I could say, okay, well, if I broke this up into triangles and take 1 vertex and start breaking it up. So from here, there's a really skinny triangle. There's another one, and I'm hoping you can see them all. Okay, so you have 1, 2, 3, 4, 5, 6. That rule that we just talked about, it's the number of sides minus 2 should give you, there are 6. There's always that difference of 2. And so you can check your answers. What is the interior angle sum of a convex octagon? So this one, how many triangles? What is the interior angle sum? And the sum, you take the number of sides minus 2. Well, how many degrees are in a triangle? 180. So each of these triangles up here has 180 degrees. So there actually is a formula. I'm going to show it to you next. But this is basically the formula. You take 180 times the number of triangles. Here's the formula I was just talking about. So we have this 180 and number of sides minus 2. This gives you the number of triangles because it's always that difference of 2. And you look at this and it even tells you, it goes through step by step. The first measure, the second measure, you keep adding. Well, it's still the number of triangles. All right, oh, see, it's not working today. This is supposed to change, but basically as we increase the number of sides, this formula still works. 180 times n, in this picture, there's 7. So 180 n minus 2. The next one hopefully will work, but 180 n minus 2, the number of triangles formed. All right, here's a corollary in addition to the theorem that we just talked about it. So if I know that the total is 180 minus 2, wouldn't to find 1 degree be 180 minus 2 divided by the total number of sides? So total 180 times the number of triangles, that's the 5 minus 2. But then you divide it by 5. So always think of that n as number of sides. So 180, 5 minus 2, this gives me the number of triangles. So you have that total, and then you divide it by the number of sides because you have 5 angles. And I believe this little visual does work. There it goes. So number of sides, notice 180, number of triangles is in that parentheses, divided by total number of sides. And notice each of the degrees for one of those degrees, interior angles, becomes bigger and bigger as it becomes more and more obtuse and opens up more like a circle. There. It's pretty cool to see. Applying this, now we can do some actual calculations. It says Jenna is building a corner cabinet to fit in a rectangular room. So think of a rectangle. A rectangle has to have a 90-degree angle. So this corner right here has to be a 90-degree angle. So it says if she builds these angles as shown, will it fit? So I'm going to actually set up a problem. So I know the number of sides. This is, if I go here, 1, 2, 3, 4, 5. It's a 5-sided polygon. So if I take 180 times 5 minus 2, that will give me the total. Okay, so 180 times 3. And you can do that calculation if you'd like. And you get 540. So these have to total 540 degrees. So I'm going to say 90 plus another 90 plus, sure, I should make that more like a plus sign, the 135 plus the 135 plus this one back here that I don't know. I'm going to call this x. Okay. That has to equal 540 exactly. So take a second, calculate that out. Figure out what all of this is. When you add this up together, it actually equals 450 plus x equals 540. We're getting closer to finding x, and I need to actually solve for x. So I'm going to go down here, subtract 450 from both sides, and you need to determine, I'm going to let you do the rest of the math. Will this angle be a 90-degree angle? If it's too big, if it's larger than 90, it won't fit in a rectangular room. If it's smaller than 90, it might fit, but it might look a little bit weird, but it could fit. But we want it to hopefully be exactly 90. So try to figure that one out. What is the interior angle sum? Look for those words like sum and each. So if I look at sum, that means I'm looking at the total. So I'm going to write an equation, 180 times n minus 2, and my n is 17. So 180 times 17 minus 2. That would give me the total. If I need to find one or each angle, then I would take this whole answer and divide it by 17. The bottom one, each angle of a rectangular n-gon measures this. Okay, this is a little bit more complicated. It's giving you the answer, and it says each. So think of the formula. 180 times n minus 2, I'm trying to write straight, divided by n, so that's the each, equals 172.8. Okay, we need to solve for n. So what I would do, I would take this, put it over 1, and cross multiply. Okay. What I would do is cross multiply, solve for n. And when you do find n, check your answer. Okay, what is the sum? It's talking sum, so remember that's the total, of the exterior angle measure of the convex polygon. Now, we haven't talked about exterior, but it does give you a solution that walks you through it. This is something I think it's really important, and they make it a little bit more complicated than I would. So I want you to visualize this. I want you to visualize, and I'll draw a little guy here. There's a little man right here, and he's walking, but he's only walking on the exterior angles, and they're numbered. So he's walking here, this amount, and he jumps over here, that amount, this amount, and for each of these. And he keeps walking, and he keeps walking, and he keeps walking, and he ends up right here where he started. So if you walk that amount and end up where you started, that's 360 degrees. Do you know that works for every single polygon? Every single convex polygon, the exterior angle, each exterior angle, the total, will create 360 degrees. And they explain it a little bit more in depth, but I think that's the easiest way to see it and the easiest way to understand it. So the sum of the exterior angles will always equal 360. All right, what is the sum of the exterior angle of the measure of a convex 17gon? Again, every single convex polygon, the exterior angles equal 360. So 360, that's it. That's the answer. The sum of any convex polygon will equal 360. All right, polygon exterior angle sum theorem, here it is. And it even tells you, hey, the rule, it will show up as 360 every time. And it even shows you visuals. And I'm going to show you this. See how these exterior angles keep changing? But the total, which it's kind of cut off, there it is. The total doesn't change. It's still 360 no matter how many sides of the polygon you have. So if you need to find an exterior angle measure and you know some things, so let's look at this. Angle 1 is congruent to 3, and angle 1 is 3x. So I'm going to label these, and we're going to try to figure this out. Angle 1 is 3x. Well, 1 and 3 are the same, so this obviously is 3x as well. And then it says measure of angle 2 is 2x. I'm going to 2x right up there. And these are both 90. So what is the measure of each exterior angle? So let's see. I need the actual degrees. So I have two 90s. I have a 3x, another 3x, and a 2x. Well, how many degrees should this equal? The exterior angles, no matter what kind of convex polygon, it should still equal 360. And you're just going to solve. Combine like terms, combine these like terms, get x by itself, and then plug them back in because it wants the degrees of each. So you need to find angle 4 and 5. Those are both 90. And then whatever you get for x, plug them back in to get each of the actual degrees. The second part of example 4, suppose that 1, 3, 4, and 6 are all the same. Okay, they're all congruent. 2 and 5 are congruent. And then the measure of 3 equals whatever angle 2 is plus 30. So I'm going to say whatever angle 2 is, I'm going to name that x because I don't know what that is. So if this is x, and angle 5 is the same, so this is x. But angle 3 is x plus 30. X plus 30, which means 1, 4, and 6 are also that same. X plus 30, x plus 30, and x plus 30. So what is the measurement of angle 4? I'm hoping you can tell these are exterior angles, and the total of convex exterior polygons should equal 360. So x plus 30, and you can actually do this a couple different ways. I'm just going to multiply. I have 1, 2, 3, 4 of those. And then I have x's, and I have 2 of those. Equals 360. That's one way you could do it. Or you could just say x plus 30, x plus 30, x plus, and add all the way around. Either way, it should be equal 360. So distribute this 4x plus 120 plus 2x equals 360. And I'm hoping you can go from there, figure out what x is, and then plug it back in to angle 4 right here. So your answer, plus 30. Finding the angles of interior angles. So what is the measure of the interior angles of a polygon? So pentagon. This has 5 sides. So you have to think back and say, okay, the interior angles, that's not the 360 guarantee. The 360 is only the exterior. So the interior, you're going to have to actually do some calculations. And the interior, take 180 times the number of sides minus 2. That will give you the total. Once you get that total, this answer should equal all of these combined. So the sum of all these. So you're going to have to take 3x plus 4 plus 7x minus 3, and we might run out of space, plus 6x plus 12. I'll just keep going. Plus 6x minus 3 plus that 90. Set that equal to whatever you get here. And then you're going to actually solve for x. So I'm going to let you do most of that work. 6x, that should be a 12 right here, just so you know. There you go. This next problem, the measure of each interior angle of a regular polygon is this. First, you have to figure out how many degrees would each interior angle equal. So I'm going to go back to that formula where it's 180. Let's see if I have enough room here. 180 times n minus 2 would give me the total interior. But I need for 1 for each, so I'm going to divide that by n. So the measure of each interior, so one interior. So I'm going to plug in 100, so I have 180 times 100 minus 2 all over 100. First, figure out what that is. Take that answer and set it equal to this and solve for x. So once you find this answer down here, set that answer equal to x, and then you can check your answer here. So the concept summary over this whole lesson, there are two main things. One, polygons have interior angles and exterior angles. The interior angle sum is 180 times the number of triangles, which would be n minus 2. So the number of sides minus 2. And if you're trying to find one of those angles, you would divide by the number of sides. So 180 n minus 2 over n would give you one angle. 180 n minus 2 would give you the total interior. Exterior angles, no matter what, if they're convex polygons, it will equal 360 every single time. I hope that helped.